Okay, in this video we'll learn how to approach creating some of the fundamental shaders and materials including plastic, parquet or wood generally, concrete and metal using the Octane standard surface shader, implementing what we have learned from the previous videos of this section. Hey folks, welcome to Mograph Plus. This video is a free sample from our course, The Ultimate Introduction to Octane for Cinema 4D. It's a massive 20-hour long course in which we explore all the aspects of Octane for Cinema 4D thoroughly. Make sure to check it out, the link is in the description. Don't forget to subscribe and hit the bell icon to get notified about our latest videos. Let's start with plastics. I'm gonna create a new standard surface material. Rename it to plastic red. And assign it to the shader ball. I'm going to open up the node editor for the material and start a render in the live viewer with the resolution locked. For plastic shaders, base color is the most important component and contributor to the final look, and then comes reflection and subsurface scattering. Let's increase the base weight to 1 and change the diffuse model to Lambertian. You can also change it to Ordinaire and lower the roughness, but Lambertian produces some nice results as well. Now, as I'll be using the same base color for other purposes, let's, instead of using the base color directly, add an RGB spectrum node and connect it to the base color. In the RGB spectrum node, load this red color from the color swatches. Now coming down to the specular reflection section, I mentioned in the specular lesson that for most materials and shaders, you can safely keep the specular reflection weight and color at 1 and white to keep the shader as physically accurate as possible. In the past, we used to adjust specular weight and color and roughness and then define very specific IR values for each shader. Just forget that. In this new approach, specular weight is almost always 1. Specular color is just a simple white, and the IR value for most daily shaders like plastic, wood, concrete, and so on can be around 1.5. The only thing we are interested in is the reflection roughness, and for more advanced shaders, probably anisotropy and anisotropy rotation can play a role in making the roughness even more realistic. We add variations to the roughness with grayscale textures, and that adds all the realism we need. So let's add a texture node, an image texture node, and load this bw underscore metal texture. And connect it to the specular roughness input. We can solo it to see how it sits on the geometry. Not bad. Let's unsolo it. Now, as this map is connected to the reflection roughness, we need to change the color space to non-color data as we learned in the ACES video, and change the type to float as this is a grayscale texture and we don't need all the channels. Okay, and that is the result we get. This is not exactly what I want. It's too rough and contrasty. I want to be able to make the bright values of the texture quite darker so we wouldn't get this very rough surface. Probably inverting the texture will result in a better look as well. So let's add a range node after the texture and use it as the specular roughness input. Now in the range node, first let's invert the values completely. So change the output min to 1 and output max to 0. This will invert the image. We can now solo the texture, then the range node to see its effect. Now to get a sharper image, we want to make the texture much darker, because remember our input is specular roughness, which goes from 0 or black or sharp to 1 or white or rough. So let's lower the output's mean value to 0.3. Now to avoid very sharp spots, we need to make the very dark values a bit brighter. So let's increase the output max value to 0.1. So that's our shader after adding the variation to reflection roughness. It's very subtle but adds a lot to the realism of the material. In terms of importance of components for plastic shaders or anything similar, now we need to work on the subsurface scattering. So come down to the subsurface tab, set the SSS weight to around 0.75. Depending on the particular plastic, the SSS amount can be quite low or high. You need to look at your reference images and see if they have a lot of SSS or not, and then decide on the weight and scale. Use the same red color that we used for the base color as the SSS color and scatter radius color. And let's lower the scale to around 0.02 in this case, or 2 centimeters. And this really adds quite a lot to the overall realism of the shader. It's beautiful. Now let's compare the shader with and without subsurface scattering. So from the compare menu, choose store render buffer. Now we can set the SSS weight to 0. Now we can see the shader with SSS on the right side and without it on the left side. Pretty cool. Let's disable A/B comparison from the compare menu and increase the SSS weight to 0.75. We can probably increase the SSS scale to something like 0.06 if we want to have a softer looking plastic with more scattering. That looks cool too. For now, let's get back to 0.02. Now, the next thing to consider is to work on the bump mapping. For most surfaces, you need an overall unevenness that can be achieved with a simple noise, and then more high frequency detail, which you can just reuse the reflection roughness map. So I'm going to connect the original reflection roughness texture to the bump input of the material. And now we need to dial in the exact bump amount that we need. We can obviously use the bump height as we talked about it previously, but it's not controllable. For now, let's just decrease it to around 0.01, the bump height amount under the geometric properties section, to 0.01. And you can see still way too much for a surface like plastic. Because I will mix a noise map as well to control the bump mapping, and probably something around 0.01 will be enough for now. I will adjust the bump height or the bump amount by adjusting the texture itself before connecting it to the bump input. We can use different nodes to do that, as we learned. A color correction node, a range node, a gradient node, multiplying it with a float texture. Let's just add a range node in this case. So let's add one after the texture and connect the range node to the bump map input. Now, if we just start lowering the output max value, we will get a darker texture, which results in lowering the bump amount. One thing I like to do when working on the bump mapping is to increase the resolution of the render and zoom in to see what exactly we get. So let me double the resolution in the live viewer and maybe zoom in a tad until the zoom value reaches 1. And for faster feedback, we can enable the render region tool and draw a smaller region to see what we get. Now let's lower the output max to 0.5. Still too much. 0.1. Still too much. 0.01. I think it's still a bit too much for a smooth surface like plastic. Let's go to 0.005. Okay, that's what I want. Very subtle, but does the job. We don't want to exaggerate anything. Subtle and little is always better. So that's the high frequency detail. Now let's quickly add that general unevenness to the surface using a noise map. For now, we can disable the render region and change the resolution multiplier in the live viewer back to 1. Most of the materials and surfaces surrounding us in real life are not made perfectly. They are not perfectly smooth. There is some sort of waviness to them. And if you take a look at any reflective surface around you, you can see that overall waviness, unevenness to them. Now to simulate that, let's add a noise map and connect it to the bump input of the material for now. You see how it distorts the reflections on the surface of the geometry. Now I can solo the noise node to see how it sits on the geometry. I'm just gonna lower its global scale to 75%. Unsolo it again. We don't want to adjust the bump height amount in the material itself, as the other bump map is already tuned for that current value. And we learned previously that you cannot rely on the bump height all the time for controlling the bump amount on your surfaces. So we can add a range node after the noise map as well to control its bump mapping strength. So let's add one. Now, if I want the effect to be stronger, I can simply increase the output max to be more than 1, like 3 for example. It's a bit too much. Let's get back to 1 for now. We can come back to it later on if needs be. Now we want to combine the two bump maps for the final bump map texture. There are different ways of doing it. The easiest one should be using a mix node. So let's add one. Connect it to the bump input of the material. Now use the first range node from the high frequency map as texture 1 input and the range node from the noise map as texture 2 input. Now if I solo the mix node, we get a combination of those two textures because the amount is set to 0.5. If set to 0, we only get the first texture, and if set to 1, we only get the noise texture. Let's set it to 0.5 to get a combination of the two, and let's unsolo the mix node to see the final shader. Now, this is a pretty good plastic shader and you can call it a day. One last thing that you can add to your shader to make it more realistic is to make the perpendicular faces a bit sharper compared to the parallel faces to the viewing direction. We can do that simply using the coat section of the shader. We talked about this specific topic in the coating lesson. For now, let's set the coating amount to around 0.5 and coat IOR to 1.2. So the coating will be limited to only the perpendicular faces. And the roughness can remain at 0.1. And this will add another level of realism to the overall shader. We can go ahead and add a bit of variation to the coat roughness, but this is enough for now. The good thing is the whole shader is being controlled with this one texture that is connected to both the specular roughness and bump input. If you load another texture, you would get an entirely different look. Let me show you the final high resolution render of this shader. Now let's quickly turn this into an orangish plastic shader. I'm going to duplicate the original one and assign it. Rename the material to plastic_yellow or orange. Now we just need to change the color in the RGB spectrum color node to any color that we want. Let's load this orangish yellowish color from the color swatches. We can also increase the subsurface scattering to around 0.06 if we want to get a softer plastic. And that's our yellow plastic shader. Let me show you a higher resolution render for this shader as well. Now let's pick up the pace a bit and go for a wood parquet shader. So create a new Octane standard surface material, name it parquet, and assign it. Now select the material, increase the base weight to 1. Let's set the diffuse model to Lambertian. As I mentioned, you can set it to Oren-Nayar and play around with the diffuse roughness, but Lambertian creates some nice results. Add an image texture node and load this parquet.png texture. Now connect it to the base color input of the material. As this is the base color texture and we are in ACES, set the color space to sRGB. Next, let's add a transform node to the texture and increase its scaling to 1.25 so it sits bigger on the surface. Now let's go to the specular reflection layer. Specular weight and color can remain at 1 and white respectively. Roughness to 0 for now. IR can remain at the default state as we discussed earlier. Let's go for the specular roughness immediately and add an image texture node. Load this parquet roughness texture and connect it to the specular roughness input. Now use the existing transform node to control the transform input of this texture as well, because we want the texture placement on the surface to match. And the specular roughness map is obviously derived from the base color map. So I'm going to change the color space to non-color data, as this is a data input and we are in ACES. If I solo the roughness texture and take a look at the texture, you notice the narrow edge between the boards are black, which if used as a roughness map will end up giving us sharp reflections in those areas. And the wood grains are also darker, which again make the surface sharper if used as the roughness texture. By inverting it, the map will be proper to be used as a roughness map. Now the easiest way to do it is through the texture itself. If you select the image texture node, you notice it has an invert checkbox. Let's enable it, which inverts the texture. Like the plastic shader, let's add a range node after the texture so we can adjust the values for the roughness input easier. So connect the roughness texture to a range node and connect the range node to the reflection roughness input. I'm just gonna make the dark values a bit brighter by increasing the output min value to around 0.1, and that would make the sharp parts rougher. Let's quickly add some bump mapping as well. I'm gonna add a new image texture node and load this parquet underscore bump texture. Use the existing transform node as its transform input so it matches with other textures, and connect it to the bump input of the material for now. If we take a look at the texture by soloing it, we know for bump maps the black pixels cause indent and this map looks right at its original state. And let's decrease the bump height to around 0.01. And obviously we can use the power value in the texture or add a range node after it. But for now, let's just work with the bump height. Now, like the plastic shader, and because we want to add the unevenness as well using a noise map, let's just add a range node after the bump texture. You can hover over a connection and click once to be able to add a node, or just do it manually. Now we can lower the output max value to around 0.75. This is still a bit too much, but as this will be mixed with the noise map later on, we will end up with half of what we have right now. Let's add that general waviness like the plastic shader. I'm just gonna steal the noise, the range, and the mix node from one of the plastic shaders and paste them here. Now connect the mix node to the bump input of the material and just connect the first bump texture to texture 1 input of the mix node. So that's our bump mapping. This range node gives me flexibility to go back and adjust the bump mapping. For example, I can select the range node for the first bump map and increase output max to something like 2 to get a stronger effect from that texture. For now, let's set it to 0.75. And finally, let's add the coats layer. Just set the coat amount to 0.3. Coat roughness to 0.1 as I don't want it to be very sharp. So that's why I don't use 0, for example. And coat IOR to around 1.25, so it's limited to only the incidence angles. So that is our parquet shader. Let me show you the final render here. Now let's go for a quick concrete shader. I'm going to add a new standard surface material and assign it. Rename it to concrete. Increase the base layer weight to 1 and use Lambertian as the diffuse BRDF model. Add a new image texture node and load this concrete 01D. D stands for diffuse. Change the color space to sRGB and use it as the base color input. For the reflection roughness map, copy the texture. Change the color space to non-color data for the same reason as the parquet roughness map. Let's invert the texture by adding an invert node after the texture. And connect the invert node to the specular roughness input. The reason I didn't use the invert checkbox in the image texture node is because I need the texture to remain at its original state, as I'll be using it for the bump mapping in a moment as well. And for the bump map, connect the original specular roughness map to the bump input of the material. And lower the bump height to 0.002. And that's a simple concrete shader. I didn't use the noise map here for that overall waviness. You can do that as well, but here the surface is rough and that imperfection won't be visible on these types of surfaces. And here is our final concrete shader. Let me show you a high resolution render of this shader as well. And finally, let's go for a gold shader. So create a new standard surface material again, rename it to gold and assign it. Increase the base weight to 1, use the Lambertian diffuse model, and increase metalness to 1. For the base color, use this pale yellow color from the color swatches. For the roughness, let's add an image texture node and load this bw_metal_02. For now, let's connect it directly to reflection roughness to see how it looks. I'm going to set its color space to non-color data as it is a data input. We can change the type to float as well. To make it sit smaller on the geometry, let's add a transform node. I want to lower the scale to around 0.63 and set its Z rotation to 245 degrees to give the scratches a bit of diagonal direction. Now obviously it's too rough. As always, let's use a range node before connecting the texture to the reflection roughness input. Actually, let's change it to an Octane gradient node instead, as it would give us a bit more flexibility and it's nice to work with different nodes. So add a Octane gradient node after the texture. And connect the gradient node to the input instead of the original texture. When I select the white nut and using the render option in the color chooser, lower its value to around 65%. If we use the range node, it would be like setting the output max value to 0.65. Then I can select the black dot and change its position to around 7% to add a bit contrast to the texture. We can solo the texture in its original state and with the gradient to see the difference. Let's unsolo to see the shader itself. Now for the bump map, connect the original roughness texture first to a range node and then connect the range node to the bump input of the material. We get this crazy result. Let's double the resolution in the live viewer again to see the render better. And we can also enable a render region to see what we are doing better. I'm going to lower the output max value to 0.1. Still way too much. Let's go to 0.01. Still, it's a bit too much as we want the surface to be smooth because this is a metal. Let's try 0.005. So that is good. Now we can disable render region and reset the resolution multiplier to 1. And finally, let's steal the unevenness combo from the plastic or the wood shader and hook them up properly. So that's our final scratched gold shader. Let me show you a higher resolution render of this shader as well. So that is how you approach creating different shaders in Octane using the standard surface material in their simplest form. Obviously, this can get much more complex. Now, you have a good foundation to build upon. It's a very simple approach. Specular or reflection roughness is the key to everything and you build around it. So in this lesson, we'll learn how to create shaders like plastic, parquet, concrete, and gold. See you in the next one. Make sure to visit our website mographplus.com and check out our premium CGI and rendering courses for Cinema 4D, 3ds Max, Maya, Arnold, Octane, Corona, V-Ray, Redshift, and much more. See you in the next one.